Got a new topic for the exam question walkthrough series of videos. So this one is chromatography. Now there's not many chromatography questions out there, so there won't be many videos in this playlist. But anyway, this is the first one. So it deals with thin layer chromatography, or TLC, gas chromatography, GC, and there's some amount of substance on there as well. I hope you like the video and find it helpful, and if you haven't already subscribed, why don't you subscribe, and you can let me know in the comments what you think and maybe other topics you'd like me to cover. As always, the link to the questions in the description of the video if you wanted to try it first. Okay, so make a start. So we've got a multiple choice question to kick off with. So TLC chromatogram for two compounds, so compound 1, compound 2. And we've got to decide, or we've got to work out, the RF value for the compound that's most strongly adsorbed onto the stationary phase. So remember, the samples would have started here. The mobile phase carries them up the TLC plate, but these compounds or components adsorb, so they bind loosely to the material that's on the surface of the TLC plate. And obviously, the stronger that is, the slower they move, or the less they move. So obviously this one here is the one that's most strongly adsorbed. So all we need to do now is measure the distance travelled by the compound, so from the origin up to there, and divide that by the distance travelled by the solvent, so from there to the solvent front. So all I've done is measured in millimetres these two distances on my iPad screen. Okay, so moving on to the next question, we've got the gas chromatogram of this cosmetic product with which has 4 esters in it, J, K, L and M, and we're told that these peak areas, or the numbers by the peaks, are the relative molar proportions. I'll just highlight molar there. So basically what that's saying is, if we look at L, it's got the number of 1. So compared to M, so M, there's 5.9 times as many moles of M, to L, 4.3 times as many K moles, 4.2 times as many J moles. On to the first part of the question, the calculation. You'll notice I've copied the gas chromatogram up, and we've got the K and M peaks highlighted. So we're told that the concentration of ester K, this one here, is 9.13 times 10 to the minus 2 grams per decimetre cubed. Remember, these are molar proportions, so the first thing we need to do is turn this concentration into moles per decimetre cubed, so just mass over mR. So there's the answer there, 5.5 times 10 to the minus 4 moles per decimetre cubed, and the mR of the ester K we can get from the table here. M over Z, the molecular ion peak, that's the mR, 166. So to scale up for the concentration of M, I'm saying scale up because it's going to be a higher concentration because there's more moles of M in the mixture. All I'm doing is taking this ratio, 5.9 to 4.3, multiplying it by the concentration of K, and that'll give us the concentration of M, which to two significant figures comes out at 7.5 times 10 to the minus 4 moles per decimetre cubed. So moving on to the last part of the question, where we've got to come up with the structures for esters J, L and M. We've got the sort of general structure there, and we've got the MR essentially, because that's the M over Z of the molecular ion peak. So J has an MR of 152, L and M are both 180. And the other thing I've highlighted here is the R part, which is the sort of the variable part, is just an alkyl group, so that's going to have the formula CnH2n plus 1. So the first thing we need to do is work out the MR of this common part, and then we'll just subtract that from the MR, and that'll tell us how heavy this R group is. So that common feature has got the molecular formula C7H5O3, so that's got an MR of 137. So that means the R group for ester J has got an MR of 15, and the R groups for L and M both have an MR of 43. So there's my 3 structures there. So the R group in J is obviously this methyl group here. I've gone for L, I've gone for C3H7, so just a regular propyl group. I could have made that M, it just doesn't matter which way around these are. So propyl group there for L, and then we just need another group but still with an MR of 43. So you can see how I've attached it. I've attached it via the middle carbon and then put methyl groups either side. So it's still C3H7, it's just joined on that middle carbon.